ನಾನು ಕ್ಲಾಸ್ ಅಲ್ಲಿ ಇದೀನಿ, ಆಮೇಲೆ ಮಾಡು. 1:30 ಮಾಡು. We discussed about electronic transducer. So the electronic transducer used in measuring of surface roughness of the surface plate. The surface plate is used in mechanical laboratories. In our machine shop, we have cast iron surface plate, and workshop also we have cast iron surface plate. In the metrology lab, we have surface plates made of granite as well as cast iron. So there, the manufacturing of granite surface plate or the cast iron surface plate, there you have to measure the surface roughness of the surface plate. Say a usual method, that is the surface roughness can be measured by using any type of comparator or electronic transducer. Electronic transducer. Say the principle of operation of electronic transducer is to, this is the plunger, this is the outside plunger, and this is the inside plunger. In between these two, there will be a flexible diaphragm. Flexible diaphragm. Flexible diaphragm. This flexible diaphragm, you can call it as transducer. This plunger or the rod, you can see here, that is connected to the tungsten filament. See, all of you observe here. This rod or the plunger is connected to the tungsten filament. So in turn, tungsten filament has two plates. That is up. That's one placed on the center of the rod. Other one is below the rod, and that plates deflects in between. The one more rod, you can observe here. These two plates deflects, and one more rod is placed in between these two plates. And the displacement coming from the movement of this plunger, if you move this plunger on the surface of the surface plate, due to the surface roughness, there will be a deflection or displacement. There will be a deflection or displacement. That displacement is amplified and rectified by the flexible diaphragm. That makes the deflection amplification by 1,000 times or million times. Imagine small deflection. You can understand the deflection may be in microns. In microns. In microns. In microns. That deflection in microns, that can be amplified by the flexible diaphragm. This diaphragm made from PVC material, or in conventional method, this diaphragm made from leather. And the other shaft or plunger, that is connected to the center of the tungsten filament. And there will be two plates which is placed on movable support. In between the movable support, there will be a rod. This rod is connected to the terminals. This rod is connected to the terminals. The terminals again, which is connected to milliammeter. Milliammeter. So the deflection coming from the moment of the plunger, which is amplified by the flexible diaphragm, that deflection is transmitted to the tungsten filament. Tungsten filament again has movable plate. That movable plate, in between the movable plate, there will be a rod which is connected to the terminal. Again, the terminal is connected to the milliammeter. Just all of you listen. the principle of operation of electronic transducer is the displacement or deflection of this plunger. The deflection is amplified by the flexible diaphragm that may be in million times or thousand times. But the deflection of this plunger makes the tungsten filament to change the electrical characteristics. Remember, the deflection of this plunger or shaft or rod makes the tungsten filament to change the electrical characteristics of the electronic transducer. Before starting this deflection or movement of the plunger on the surface of the surface plate, bring the milliammeter to read 0. That is nothing but make the milliammeter to read 0. Bring the milliammeter to read null balance. Read null balance. Then make the plunger to move on the surface of the surface plate. That surface waviness or roughness changes the electrical characteristics of the tungsten filament, and there will be a deflection of the plate. So due to this, there will be change in the electrical current. That current is accepted by this rod. This rod is connected to the terminal, and the terminal is connected to milliammeter. In the milliammeter is directly calibrated into the surface roughness, that is in microns. That is in microns. This is the principle of operation of electronic transducer. Next, come to the point. In the examination, you have 3. Among the 3, one is 100% guarantee in the module 4. Module 4. So that is the mechanical transducer. The mechanical transducer means a dial indicator. All of you seen, all of you performed the experiment in the metrology lab. That is the measurement of the taper. The measurement of the taper of the cylindrical component and also the tapered component. There you have used the dial indicator for measurement of taper. Next, come to the point. After starting of the college, after removing the lockdown, in the metrology lab, you have one more experiment, that is the LVDT, linear variable differential transformer. You have to measure the strain by using linear variable differential transformer. That is called as electrical transducer, where you have to measure the deflection of the shaft or the movement of the shaft or these two experiments. One is a mechanical transducer, that's dial indicator, already performed in the metrology lab. One more experiment is there, electrical transducer. In that linear variable differential transformer, you have to conduct the experiment using LVDT. Next, come to the point, very, very important. All of you mark it, very, very important. This time, you can expect this question in the examination. Expect this question in the examination as well as in the test. Write down, all of you. Write down. Explain briefly. Explain briefly with the neat sketch. Explain briefly with the neat block diagram. Otherwise, write down like this. Explain briefly with the block diagram. All of you write down the question. You have this question in the test as well as in the examination. You can expect this question in the examination. Almost all the question paper, you have this question. Explain briefly with the block diagram, generalized description of a measuring system. This question, you have this question in the examination for 10 marks. 10 marks. First, write the block diagram and explain the following 5 blocks. 5 blocks with your own sentence. No need to reproduce the same explanation you have in my notes and you have in the textbook. Go through the explanation of the generalized description of a measuring system and write down with your own sentence. First, for example, with respect to this measuring system, I explain the working of digital weighing machine. Digital weighing machine. Say, with respect to this block diagram, I explain the principle of working of electronic weighing machine, which is used in chemical laboratory and weight bridge and almost all the grocery and provisional shop. You have electronic weighing machine. See, with respect to electronic weighing machine, you have to study the generalized description of a measuring system. First, measured medium and measured quantity. What is this? Measured medium means you have to measure the unknown quantity. Say, for example, if you place 3 kgs of sugar on the platform provided in the electronic weighing machine. Electronic weighing machine. That is, the weight is in kgs. The weight is in kgs. That is measured quantity. The measured quantity is weight is in kgs. Next, the very first block diagram is the primary sensing element. Primary sensing element. With respect to the weighing of 3 kgs of sugar, what is the first function? You fill the cover with the sugar that may be more than 3 kgs, that may be less than 3 kgs. Place it on the platform or the base provided in the weighing machine. Due to that, the force acting on the platform, that is primary sensing element. If you keep the sugar cover on the platform, which exerts the pressure on the platform. Next, come to the point, whichever the force or load coming from the primary sensing element, which is fed to the second element in this description of measuring system, this is variable conversion element. Variable conversion element, that is nothing but the instrument or measuring element which receives the input from the primary stage, and that input can be converted, filtered, amplified by the variable conversion element. That element converts the load coming from the primary sensing stage. It is converted into analogous form. Remember, the variable conversion element convert the input, that is load, into analogous form. That analogous form input, the analogous form is fed to the variable manipulation element. That analogous form coming from the variable conversion element is fed to the variable manipulation element, which receives the input signal in the analogous form. It is converted into voltage signal, which is converted into voltage signal by the variable manipulation element. This variable manipulation element may be amplifier or rectifier or any instrument which manipulates the analogous form into the voltage signal. The analogous signal is converted into voltage signal in variable manipulation element. This voltage signal is fed to the data transmission element. This is the intermediate element. The function of this data transmission element is whichever the voltage signal coming from the variable manipulation element, with this element, data transmission element, the name itself indicates which is converted into digital form, which is converted into digital form. That digital form signal is presented to digital output. Digital output, that is data presentation element. That is data presentation element, where you have the output, that is the weight of the sugar, which is placed on the platform of the electronic weighing scale. Here, the data presentation element presents the weight of the sugar in kgs. Say, for example, you need 3 kgs, which shows 2.80 or 3.10, for example, which shows the output in kgs. That may be the required, or that may be less than the required, or more than the required. From trial and error method, remember, trial and error method, you can bring down the weight of the sugar to the 3 kgs. You can add the sugar to the cover or remove sugar from the cover which contains the sugar. Bring the output to read 3 kgs. To read 3 kgs. The data presentation element presents the data in the required form, that is the output of the measurement, or that is the result of the measurement, that is in units. In this case, unit means 3 kgs. 3 kgs. All of you observe here. That is the presented data. That is the presented data. The presented data, that is weight of the sugar in 3 kgs. The weight of the sugar is 3 kg, or weight of the sugar is 3 kgs. And the observer understand that the medium that he can understand, that is the weight in kgs. Weight in kgs. The observer understand that the weight of the sugar in kgs. So this is the generalized description of a measuring system. All of you mark it very, very important. You have this question in the examination as well as in the test. All of you write down, explain briefly with explain briefly with the block diagram. Explain briefly with the block diagram the generalized description of a measuring system. First, the measured medium and the measured quantity. The measured medium is weighing of the sugar by using electronic weighing machine. The measured quantity, that is the weight of the sugar. The transformation or translation, the weight of the sugar, weight of the sugar you have to measure. So in the primary sensing stage, keep the sugar in the cover on the platform of the electronic weighing machine. Due to that, the load acting on the platform, that is converted, that is transferred to the variable conversion element through the sensors in the bottom of the platform. There will be strain indicators, strain indicator or strain gauges. That strain gauges are connected in keystone bridge. Due to the change in the resistance of the keystone bridge, there will be the output. There will be the output. The output is in the analogous form. That is the analogous signal coming from the primary sensing element is fed to the variable conversion element. Variable conversion element. Whichever the input coming from the primary sensing stage, here the same analogous signal is amplified, rectified, filtered, and fed to the next stage, that is a variable manipulation element. This receives the analogous signal and convert that into voltage signal. Again, the voltage signal. That voltage signal is converted into digital form. That is digital form. In the downward transmission element, whichever the voltage signal is coming from the variable manipulation element is converted into digital form or digital signal. That digital signal can be read from the digital indicator, which presents the result of the measurement, that is weight of the sugar, that is 3 kgs, that is in kgs. The data presentation element is nothing but the electronic weighing machine, where you have the digital indicator which presents the data that can be understood by the observer. That is, weight of the sugar is 3 kgs. The output of the measurement is 3 kgs of sugar. The presented data, that is in kgs. That is in kgs. This is the generalized description of a measuring system. Almost all the question paper, you have a question on write the generalized description of a measuring system or explain briefly with generalized description of a measuring system. That is almost all the question paper. You have this question in the examination point of view. This is very, very important. Mark it important. You can expect this question in the examination as well as in the test. So today's class, this much is enough for you. And now I conclude this class and I will continue in the next class. Say, all of you listen here. That is generalized description of a measuring system. Now I conclude this class and I will continue in the next class. I make unmute to all. If you have any questions, please ask me. Tell me. Karthik, can you listen? Kevin, can you listen?
Yes, sir.
Do you have any doubt?
No, sir.
No. Okay. Kruti, do you have any doubt?
No, sir.
No. Okay. Now I stop at this stage. I will continue in the next class. Okay. Thank you very much.